photo. And now today there is a lecture on time response of a system. You see here, what is the time response? Response is nothing but output. When the system is giving a response for a response with respect to time, for a given excitation. Excitation is nothing for a given input. Whenever there is an input, then the output or a response with respect to time is called time response. The time response chapter I will divide into four parts. The first one is called standard test signals or inputs. Standard inputs. Second one is called time response of first order system. Time response of first order system. Second, time response of second order system. And the fourth one is called steady state error or error coefficients. Steady state error or error coefficient. There are four parts: standard test signals or standard inputs, time response of first order system, time response of second order system, and steady state error and static error coefficients. Okay. Now we'll see first what are the standard test signals or standard inputs. Okay. The question is like this: explain standard test signals. Basically there are four types, but still we will divide into five. Basically there are four types. So the fifth one is a sinusoidal input. There is a separate model, but still I will consider there are five inputs. There are five standard test signals. The first one is called what? Step input, and second one is called a ramp input or a signal. Third one is called parabolic input or a parabolic test signal. The fourth one is called impulse input or impulse test signal. The fifth one is called sinusoidal input, a simple harmonic input. So there are five types of inputs: step input, ramp input, parabolic input, impulse input, and sinusoidal input. Now we'll see first what is a step input. What is a step? The first one is called step input. The step input, the constant input is a second, x-axis, y-axis is called r of t, input. Suppose you are given magnitude is A. You take any system. Suppose you are given a 10 Newton meter square pressure to a one system, constant input, 10 ampere current of 20 volt to the system, otherwise 13 Newton meter torque to the system, constant. You are not varying. Suppose daily you are studying 2 hours. Okay, for a week there is a constant 2, A equal to 2. Now I'll write the equation. It is like an equation y equal to 3 independent of x. Here y is r of t, x is t. So r of t equal to what? A. T is greater than or equal to 0. Now I'll take a Laplace. Laplace of r of t, that is a Laplace of 1, because nothing is 1 is equal to what? T is to 0. It is a time function. And whenever the time function, I can take a Laplace. And you know that Laplace of t is to n equal to n factorial divided by s is to n plus 1. So here r of s equal to a. What is the Laplace of 1? 1 by s. So if a equal to 1, r of s equal to what? 1 by s. This is called unit step input. Suppose your input is 1 volt, suppose your input is 1 ampere, suppose your input is 1 Newton meter torque, or suppose your input is 1 Newton force. This is called step input, this is called unit step input. You can write in the time domain also. Laplace inverse of 1 by s is what? 1. So I can write reverse also. So r of t equal to 1 or r of s equal to 1 by s is called unit step input. Okay, next is called parabolic input. So second one is called ramp input. After that there is parabolic. Ramp input. Ramp means what? The slope goes on increasing in a linear fashion. So this is called a ramp. Okay. So ramp it is a line, so it has a constant slope. It may be 1, 2, 3, whatever. Or in a degree, 10 degree, 20 degree, 30 degree, constant. So this r of t, this is called time t. The equation of line passing through the origin, no constant, y equal to mx. Here r of t equal to what? At y mx, y equal to mx. Now I'll take a Laplace. Laplace of r of t equal to a Laplace of t. So r of s equal to a. What is the Laplace of t? 1 factorial divided by s square. Okay. Fine. Because Laplace of t is to n equal to n factorial divided by s is to n plus 1. We know this. If a equal to 1, then r of s equal to how much? 1 by s square. This is called what? Unit ramp input. In time domain also reverse, Laplace inverse, this equal to t. Okay, because Laplace of 1 t equal to 1 by s square, and Laplace inverse of 1 by s square is equal to what? T. But you have to remember this. Unit ramp input is the thing, but r of s equal to 1 by s square is called, r of s equal to 1 by s square is called unit ramp input. Next one is called parabolic input, third one. Here also the input goes on increasing in the exponential form or in the parabolic form. So the third one is called parabolic input. In the parabolic input, the input is like this. It goes on increasing with respect to time. So it has an infinite number of slopes. Now I will take particular slope at a particular time. So now the slope becomes what? At. So half parabola, I can write the equation of r of t equal to at square when t is greater than or equal to 0. I can write a by 2 also, suppose, because half parabola. So I can write a by 2. If I take, because 2 get cancelled further, if I take a Laplace of r of t is equal to a by 2 Laplace of t square. So r of t becomes r of s, a by 2 The Laplace of t square is equal to what? 2 factorial divided by s cube. We know that Laplace of t square is equal to 2 factorial divided by s cube. Okay. So now 2 to get cancelled. R of s equal to a by s cube. If a equal to 1 suppose, then R of s equal to what? 1 by s cube. What is this unit? Parabolic input. I can write in t also, the time domain, Laplace inverse of 1 by s cube is equal to t square by 2 factorial, that is t square by 2. Here I can write t square by 2, but I have to remember this, the s form, R of s equal to 1 by s. It is called parabolic input. Okay. The fourth input is called impulse input. The fourth input is called impulse input. The fourth one is called impulse input. It's nothing but what good example, hammering action, large force for a shorter period of time. And extent happens, the large force for a shorter period of time. If the light, the supply comes for a fraction of a second, it goes. The voltage for a fraction of a second. So in this case, this is a special type of input, because this type of input using the patients also to give a shock to the patient. In many process, for in a hardening process also, okay, large force impact for a shorter period of time. So here R of t and t, here large force A is called large magnitude, A is called a large magnitude. It may be force, it may be voltage, for a shorter period of time, because delta t is nearly 0, not exactly 0, nearly 0, 1 second, 2 second, in 2 second, in 3 second. So that is a t tending to 0. So now R of t is equal to area, this area is A into delta t, but delta t is nearly 0. If I take a Laplace, the R of s equal to A. If A equal to 1, then R of s equal to 1. It is called what? Unit impulse input. It's called unit impulse input. R of s equal to 1. And next one is called, the last one, actually in the time response 4 inputs are sufficient, but in the frequency response there is a special type of input, is sinusoidal input. Okay. So, but still I will cover the fifth input, that is called what? Sinusoidal input. The fifth one is called sinusoidal input. So in this case, when the input is sinusoidal, output is also sinusoidal. Input is sinusoidal, then output is also sinusoidal. And with the same frequency, only the difference is different magnitude. Suppose the input is, that is called A, that time, so R of t. So what will write? R of t equal to A sine of omega t. It has a frequency. Okay. Now the frequency omega is equal to 2 pi f. In the f is in hertz, we know. Some hertz per cycles, hertz is nothing but what? Number of cycles per second is called hertz, and we will convert into standard unit is omega is equal to 2 pi f in radian per second. So if I take a Laplace here also, Laplace of R of t is equal to A Laplace of sine of omega t. Next, R of s equal to a omega by s square plus omega square, because Laplace of omega t is nothing but omega divided by s square plus omega square. If a equal to 1, then r of s equal to omega divided by s square plus omega square. It is called unit sinusoidal input. Okay. Now I'll revise all the 5 inputs. Because these are the inputs for a different application. For some application, ramp, parabolic, or step. Suppose I want to apply the brake when the bike or a four-wheeler has some particular 60, 70 kilometer, 80 per hour, then you are not suddenly applying the brake step input, unit step input. No, you are reducing through the ramp. Slowly goes on increasing the force. Even it may be parabolic. Suppose if accident will happen because suppose somebody is very near to your automobile, suddenly you are applying a brake, that is called impulse input. Then output is also like an impulse only. So the system will behave in a different manner with respect to different type of input. That we'll see in the next class. That is called time response of first order system as well as time response of second order system. Here I'll revise all the inputs once again. Okay. Shortly, within a minute I'll complete. So that is called step type of input. So we have seen the first type is what? Suppose say serial number 1, 2, 3, 4, 5. Type of input is, suppose I'll take unit step input and unit ramp, then unit parabolic, then unit impulse. Okay, I'll take 4 only now. The sinusoidal. Then what is the R of S here? R of S is 1 by S, 1 by S square, 1 by S cube, and impulse input is 1. Unit step input is nothing but 1 by S. Okay, in R of t, there is a different story in R of t. If just you take a Laplace inverse, you will get R of t. While solving the problem, oftenly I am using, whenever in the problem you will mention unit step means you take R of S equal to 1 by S, unit ramp is 1 by S square, unit parabolic is 1 by S cube, unit impulse. Sometimes problem will ask like this, the input is unit step input and unit ramp input. In that case you have to write 1 by S plus 1 by S square. Sometimes it may be the combined input also, it is also possible. Sometimes combined 3 inputs. So in this lecture we have seen the types of inputs, the 5 types basically, and we have seen the mathematical modeling or equations in terms of Laplace. Yes. Okay, in the next lecture we will see the time response of first order system. Okay, I hope you understood. Thank you.